last year, past year final exam lah. Given you a lot of data. It's like 20 data, but then you have to select, okay? And for sure, it's asking you to find the differentiation of one of the data, but then you have to look at the step size. You have to find your own. Which one is you have to take which step size, because when there's a list of tables, they have a different how to say, different step size, and then you have to choose. I think I think later on I will give the tutorial that I give. Actually is one of them already is the past year questions already. So if you know how to answer, that's probably that is the soalan a question that will come is a final similar something like that lah. So you have to know how to choose it and how to use the correct difference formula, because we have, for the first derivative we have 5 difference formula. So which formula you will have to use, and for the second derivative we have 2. Okay, so which one you are going to use? Okay, normally in the task or final, they ask you to use appropriate formulas, so you have to find all the formula that can be used. Okay, so now I continue with chapter 6. Okay, so okay, so okay, if okay then type okay. Not okay then I will have to have to discuss back on chapter 5. Okay, so okay, now so then I will continue with chapter 6. Okay, chapter 6, numerical integrations. Okay, wait, I have to, so saya nak tulis, so I have to turn off. Okay, by the way, this one, the recording, I can record, but then I cannot download or even like I share to you, but it can only, I think that it can only be seen for within 7 days. If you have another screen recorder or what, you can probably can record this Google Meet, this class. So I try, let's see in maybe let's see like coming weeks with coming class whether I want to just stay using Google Meet or try to change to team, Microsoft Team. And Microsoft Team can record, right? I guess all of you got, I don't know, I haven't have Microsoft Team. So the sama je kan, Zixing is more easier, right? So yeah, so I think maybe next class I will try a Microsoft Team, then so that I can record our class so that you can refer back the video. Okay, so good job, so probably with but please remind me, I scared like I forgot already. So because I already used to Google Meet actually. Oh, I cannot record already. Actually, I cannot record. Kalau boleh awak record sendirilah untuk kelas ni. Tak dapat record lah saya. So you just record yourself, okay? Boleh Okay. Siapa baru masuk? Wait, I open the numerical integrations. So okay, as we continue with chapter 6. So chapter 6 is numerical integration. So in this chapter, okay, you will learn, okay, in this chapter, basically, actually, we have a few methods, okay. The first one is trapezoidal rolls. Second one is Simpson's one-third roll. Third one is Simpson's 3/8 roll. And then fourth is 2-point, 2-point and 3-point. 2-point and 3-point Gauss quadrature. So basically, 2-point and 3-point is the same, only we have to change the formula. Okay, so the topic that cover in your syllabus is actually Simpson's one-third roll, Simpson 3/8 rolls, and this 2-point and 3-point Gauss quadrature. The trapezoidal rolls is not covered in your syllabus, but then I will explain to you these trapezoidal rolls because it is a basics of the numerical integration, so that you will be more easier to understand. Okay, so why we need to do these numerical integrations? Okay, so any idea? Any of you have the idea why we have to do these numerical integrations agak-agaknya? Fatin, Nur Aina. Kalau video yang saya numerical differentiations, why we need to do this, why we need in chapter 5, why we solve the differentiation using numerical differentiations. Fatin Nur Aina.
Ya, saya.
Agak-agak kenapa we use this integration tu we use in a numerical method? Ada tengok video sebelum dia?
Ada. Untuk tengok rate of change ke?
Rate of change, that is the slope, because of that is the differentiations. Tapi integrate dia bukan rate of change. Apa lagi? Why we need this one? Don't know. Fatin tak tahu. Integrate, definite integrals. That means you don't know how to. Okay. Ziqing said that because we want to integrate definite integrals. Yes, it can be said that because of the function is too complicated and we cannot find the exact solutions. Okay, we can use this one. Okay, this one. Why we use this one? Why? Okay, first and foremost, when we have the function that is complicated, complicated, or we can say that we do not have the exact solutions. For example, let's say when we have like this one is a, b, right? This is a value, square root. When you have like a square root of like this, so you don't have the exact. It can be positive, can be negative, or I'm not sure. Okay, so don't have the exact solutions. So we can use this one, numerical integration. And sometimes we also we can use numerical integration when we want to do the integrations but we don't have the equations, because that only data is provided. Let's say this one, right? Normally we want to do integration, we have to have this one, fx dx kan. Ini, this fx is not given, so we cannot solve this one using the integration analytically. So that means maybe at that particular problems only give you the data, only have the data, only data is provided, provided. Okay, for example, let's say we have like x, y, and you have 0, you have, let's say 0, something like this, 2, 12, let's say. But you don't have the function, this one, fx. What is the fx? You don't know. So that, but you have the data. So from this data, we can use this data to do the integration by using numerical methods. So that's why we can use this numerical method. And what's the difference between integrations and differentiations? Differentiation is, okay, just now rate of change, okay? Tadi siapa cakap, tadi siapa dah? Aina, apa Fatin Nur Aina, I said rate of change. Okay, let's say we have a graph, right? Let's say we have a graph. Let's say we have a graph, right? So if we are doing the differentiations, that means when we have a graph like this, when we want to find the slope, right? Rate of change, the slope or gradients, normally this one. We want to find the slope, the tangent line here. Slope or the gradient. Ataupun rate of change. Okay, so but when we have a graph, the same graph, and then if you say we want to do the integrations, that means actually we want to find the area under the curve. And from this area under the curve, area under the graph ataupun curve lah. So from this one, let's say this is A, this is a B. So this is from A to B. Let's say this let's say this function, this line is a fx. So this is a fx dx. So from this area, and for sure from this area we can find the volume. Okay, kalau lah we have another, dia punya another dimension, maksudnya mungkin dia punya length ke, mungkin dia punya depth ke, so you can find the volume of these particular problems. So you can find the area or even you can find the volume. Okay. So I give you an example. Okay. For the numerical methods, when we want to do the numerical integrations, the basic way we use the trapezoidal rows. So explain this one first, even though this is not covered in your syllabus, but I explain a little bit. So, and you know what is the trapezoid? Trapezium kan? Trapezium, what is a trapezium? So trapezium basically is something like this, right? Right. So where you have a shortened length, okay, another is a longer length, and then we have like this one, this distance, this h. So in order to get the area, the formula of area of this trapezoid is 1/2 times with A plus B times with H. Right, macam ni kan? This one I guess you'll learn in the primary school lagi mungkin. Okay, so back to this one. If I'm too fast, let me know, okay? If I'm too fast, let me know. So far, okay? Semua okay? If okay, then you type 1. Too fast, then type 2. Oh, sorry, Shafiq, I didn't notice your message. To find the approximate value, that's correct, but for sure, okay, sebenarnya all the syllabus you learn in the numerical methods, we only find the approximation value. We didn't find the exact value. Sebab setiap kali kita buat ni, dia bukan the exact solution. So normally we have the error. Cuma kadang-kadang Syafiq, untuk numerical method ni kan sebenarnya semua yang awak belajar ni tak kisahlah chapter ni ke chapter sebelum ni, integration, numerical integration or numerical differentiation or even system of linear equation, sebenarnya kita cari approximation value sahaja. And then that's why you remember in chapter 1 we do the absolute error, we find the error. So And then in the chapter 2 and 3, remember when we do the Gauss elimination methods, and then or even like bisection or Newton divided difference, we have to do until the nilai certain value is less than epsilon, less than 0.005 or 0.05, because we want to make sure the error is small as possible until kita boleh accept. Okay, boleh Shafiq? Okay, so I'll go back to this one. Okay, go back to this one. Okay, thank you so much for your response. Nanti saya ingat saya seorang cakap, lepas tu saya dah hilang daripada radar. Okay, let's say we have a graph like this. Okay, we have A from A until B. So I want to find the area under the curve. That means I want to, saya tukar color. This one. Make it become trapezoid. This one. It's coming soon. Sekarang tak ada. Never mind. This one. If I draw this one here, again, this one. This is the trapezoid. Okay. Let's say I want to find the area, this one, the area of this trapezoid, this area A. Okay. So in area A, let's say we have start from A until B. And then let's say this one, here, the length of this one is actually B minus 1. Okay, so this B minus 1. Let's say at this point, this is at X is A. So at this point, this is Fx not katalah. Let's say I change this one become X not, B become X1. So at this point, this is Fx1. Okay, the value of Y is actually the value of Y when X is X1 lah. Okay, and this one is the value of Y when X is X0. Okay, and if let's say I do this one, so the area is half. Kalau ini this one, okay, this one is this one lah. Okay, F X0 plus with this one, the length of this one. The length of this one is actually Fx1, okay? And then time with the H, ini and H, this one. So that means B minus A. Okay, so this become B minus A divided by 2 Fx0 plus with Fx1. Okay, this one. So, but then if you look at here, actually we want to find area under the curve, and this one is we already overestimate already here, extra. So these two things is actually this can consider as an error. Here, this one underestimate and the underestimate, and here is overestimate. So here is the error. So when look at this one, the trapezoidal rolls, they will have a lot of error. Error yang banyak ini kat sini. So in order to reduce the error, then we divide this segment, this this area into several segments. Okay, okay. So I go to this one. The same graph, okay, the same graph. This one we do in one. How to say, one area. Okay, we calculate in one segment A. Okay, area of A. Now I divide it into several segments. Okay, like this one. If let's say I divide it into 4 segments, let's say. Let's say this is half and this is. Okay, let's say the same graph I divide into 4 segments. And let's say this one, here is the X0. Let's say here is the X1, here is the X2, X3, and X4. And all these, the H are same. Let's say the step size is same. Okay, this one is the same. And this point is F, X0. At this point, this is F, X1. This point is F, X2. This point is F, X3. And this point is Fx4. Okay, now if let's say I want to do the area, find the area under the curve. So that means here I will draw this one. This another trapezoid. So you look, if you can see the error, this is the error. And so the error is becomes smaller compared to just now. So we will divide into 4 like this. So we divide into, this one is a A1, A2, A3, A4. So we divide into 4 segments. So the area will be, so now it's at N. We call it N lah, segment, based on the how many segments, N. N is 4. Okay, so near, if let's say we divide, you look at here, when we want to find the area, we have to find area is equal to A1 plus A2 plus A3 plus A4, right? So where the A1 is 1 over 2. Okay, so this one is X1 minus X0. This one here, X1 minus X0 time with Fx0 plus Fx1. And this one, A2 is equal to 1 over 2 X2 minus X1 Fx1 plus with X2. And A3 is 1 over 2 X3 minus X2 Fx2 Fx3. Therefore, A minus 2 X4 minus X3 Fx3 plus if Fx4. Okay, so you look at here. So where A1 here, sorry. So A1 is actually this line. Right. So this one will be X1 minus X0 here. Right. Where the X, this one, Fx0 plus if Fx1. And this is the second area. Second area. And where the second area, we have X1 and X2 here. X1 and X2. Okay. And then when this one, the third one is A3. So A3 is here. So A3 from A3 minus A2. And then here, 2 Fx2 plus Fx3. Wait. Now here, this one, A4. Here is the A4. So A4 is from X4 minus X3. And then Fx3 here plus Fx4. Okay, if you look at here, okay, what you can see here is actually when we do the integration from A to B, this Fx dx, what we can see here is that actually this is a H, this is a H, step size, all this one H divided by 2 actually. And then you look at the first one, Fx0, the first one, this one appear once. And then the last one, Fx4 appear once as well, one time only. But others, for example, this one, Fx1 appear twice, 2 kali. And then Fx2 appear twice, 2 kali. Fx3 appear 2 times as well. So dia jadi formula dia macam ni. F0, the first one, 1 times, plus with Fn, the last F, plus with 2 summation of Fi. Okay, so this is the formula of, basically, this is a formula for the trapezoid rolls. Okay, trapezoid roll. So trapezoid roll can be one segment, but when we want to make the area become smaller, we can divide into few segments. Okay, so far okay or not, class? So far okay? Boleh? So okay, tak okay? Can doctor? Okay. Tak okay, okay? Okay, boleh. Okay, now Syafiq seorang okay. Yang lain okay ke tak? Only Syafiq are okay. How about others? Okay. 3, 4 je. 5. Our class we have 50, but now after sign in the attendance and then go out already few. Okay, thank you. So we continue. Okay, now this is the basic. Okay, when we have more segment, for sure the error will be reduced. Smaller, the error is smaller. Okay, now I want to explain to you Simpson's one-third rule. Okay, sekejap saya copy ini dulu. I copy this one first. Later on do another. Copy. Paste here. Let's continue with a Simpson 1/3. Sekejap Wait I open my open my notes. Okay. Sim besar sikit. Simpson's one-third rule. Okay, so Simpson one-third rule is actually, okay, from this A to B, okay, we divide it into a sub-segment where the sub-segments, I call it N, is the even number. That means even sub-segment. Okay, just now I divide into 4. Okay, divide into 4. Okay, so but it's not necessary, but this one is the previous one I explained. But if let's say we want to use Simpson one-third rule, we have to divide this one into a even number. So this one 4, okay, we can use Simpson one-third. So either n can be 2 or 4, 6, 8, and so on. That means multiple of 2. Multiplication of 2. Okay, so let's say this one. Okay, let's say daripada just now, we have 4 segment just now. From just now, saya pecah kepada 4 tadi. Just now, we already. Okay, this one is based on the previous one. Okay, let's say I have this 4 segment. So from this 4, saya pecah lagi kepada 2. Yeah. So now, so I divide it into 2. Okay, so each of them become 2. Okay, so now if you look at here, I will have more points. So let's say this one. Here. Even though walaupun saya pecah kepada 2, even though I divide into a few segments, 2 segments, but it's still, this one is A1. Okay. And let's say this one. Here. This is A2. A3, A4. A3, and this A4. Okay. But the step size, the H here, Sekarang dah tukar. Now the H is here. This is H. This is H. So dia punya H pun sama. All the step sign are same. All are H. Boleh? Semua tu sama. All are H here. The step sign here is this is H. So that now kalau tengok saya sekarang saya tengah I change here. So total we have 1, 2, 3, 4, 5, 6, 7, 8. Now I have 8. And then kalau lah, okay, this H here is, okay, now you look at, now we have how many N? H, if let's say you don't, let's say the question didn't give the H. So only give the from A to B, and then we have to divide into how many segments. Okay, if let's say we want to use Simpson 1/3, that means the segment we have to divide into the even segment. Okay, so that means the H, now we want to find the H. What is the H? The step sign. So H is B minus A divided by N. Number of the segment. Okay, N is the number of segment if H is not provided. So this equation, actually you have to remember. If let's say the step size is not given, H is step size lah. Okay, if let's say step size is not given, then you have to know that the step size have to find by using this formula. B minus A divided by N. N is the number of segment. Okay, now we want to find the area. Okay, area. So area, the total area have to be A1 plus A2 plus A3 plus A4, right? So let's find the A1 first. So A1, okay, so if let's say look at here, A1, if let's say I put this one is X0, and here this one is X1, and here boleh nampak lah. Sekejap. Oh. Let's say this one is X0, this one is X1, X2, ini X3, X4, X5, X6, X7, and B is X8. So for A1, this one, that means if we integrate, start from X0 until X2, okay? Right, Fx dx, right? So now become H. Dia punya formula, kalau untuk the Simpsons with the formula macam ni. The common formula is like this. A, when we have A into B, Fx dx, the approximation of integration is H divided by 3, F0 plus 4, F1 plus F2. So where this one, F0 is the yang first lah, first, and F2 is the last one. So you look at this one, it will become like this, H over 3 equal to, sorry, not equal to. F X0 plus with 4, you look at here, this is first one, and this is second one. This is F X0, this is F X1, this is F X2. So the middle one, yang tengah ni, this one, is have to time 4 plus the last one, F X2. So far boleh ke? Yang tengah-tengah. Yang tengah-tengah ni kena darab 4. This one. At the binder, this one. So same as X2. So X2 is H over 3 time with, okay. So dia start dengan, if you look at this one, it start from Fx2. And then middle is Fx3. And then here is the fx4. So here like this, fx2 plus with 4 fx3 plus with fx4. Boleh ke? Now A3 is h over 3. So A3 start from x4. And then tengah-tengah at the middle is f x5 plus with f x6. And then A4 h over 3 f x5 plus with 6 4 f x7 plus with f x8. Macam mana saya dapat nanti? How I can get this one? All understand or not? Boleh? Semua okay? If you're okay, then you type 1. Okay. Seorang je Mastura. Okay. Okay, now, let's see. If you look at here, Ahmed, you understand or not, Ahmed? Okay, if you look at here, yang 4, this one, 4 times fx1, and then 4 times xx3, 4 times xx5, 4 times fx7. Actually, if you look at here, most of the odd number, those odd number, we have to time with 4. Boleh? Odd number yang ganjil. 1, 3, 5, 7. Kan? 1, 3, 5, 7. And then, if you look at the even number, this one have to appear 2 kali. And then this one, F4, appear 2 times. Okay, what I said appear 2 times because the total A is A1 plus A2 plus A3. Oops. Plus A4. Can. So that means I have to total up all these things. All have to total. So that means this is, and then you see this one, F6, fx6 also appear 2 times. So the common formula for Simpson's wanted row become like this. Become h over 3, okay, f0 plus fn, where the first one, you look at here, the first one, this is the first one, appear only once. And then this one is the last one, fx, the last one, only appear once. Cuma sekali saja. But then the rest, this one, 4 times summation of fi, where the I is the odd number, and then 2 times summation of fi, where this one is an even number. Boleh faham tak? Okay, so this is the formula. So, and remember, if you want to use Simpson wanted row, the n have to be even. Okay, must be even number. Multiplication, multiple of 2. Okay, multiple of 2. Kalau lah is not even number, we cannot solve using Simpson wanted row. Okay, maybe I try one example using the Simpson wanted row, and we will use this formula to solve. Okay, try 6.3. Sekejap wait lah. Okay, this one is example 6.3 in page 132. Okay, say that approximate integral from -2 to 0 for 1 over 1 plus epsilon power of x ds by using Simpson's one-third rule with n equal to 8. Okay, so look at these questions. So the n, the number examined kat sini dah bagi. Here is already given that n is 8. So this is an even number. So that means we can use Simpson one-third rule. Okay, boleh use. Can use Simpson's. And then this one is the lower limit. Kalau sebelum ni, we can use this one is as a A. And here, this is the upper limit. So upper limit is B. Tak nampak pula ni. Okay. So the first and foremost, we have to step 1. Step 1, we have to identify H, step side. So H is B minus A divided by N. Okay. So kalau kat sini, B is 0 minus negative 2 divided by number of segment N is 8. So here is 2 over 8. 2 over 8 then means 1 over 4, 0.25. So the step size is 0.25. So mean that like this. We have to find, kalau let's say we have a graph, let's say I have this one. Let's say graph, right? Here is a negative 2. So the next value is here 0.25. That means here this is the negative 1.75. And the next one is negative 1.5. And then next one is negative 1.25. And so on. So until Z 0. So where this one is the step size is the semua sama. Okay. So step number 2, once we already have the step size, get the step size. Now step number 2, we have to solve this numerical integration using table. So using table, if you are using the calculator, either these two calculator. One is this FX 570EX9. Another one is this one. I go and find this one. FX 570EX, and another one is this Casio FX 570ES plus. Then you can do the table, okay, using that calculator. If you are using Casio FX 570MS, MS, you cannot do the table using calculator. So you have to draw the table yourself. Okay, this one, step 2. Panggil apa? Just now, page 132. Sorry, wait. I opened the book. Just now I will open the book. Okay, so this one is step 2. We have to draw the table. So now we have to draw the table like this. There. Okay, start with, we have a I. Tak ada masalah pun awak guna calculator lama. Even that using all calculator, that is okay. So sini cuma I will put this one for the fx. Saya akan pecah kepada, here this one is a fn naught, and then this one I put f odd, and this one is f even. So like this. So mesti ingat, you have to remember that every time the I will start with 0. So this one, we will start with the nilai. This one, the first one, we will start with the lower limit. Lower limit sampai ke last one sekali is the upper limit. So kalau lower limit here, just now, the lower limit is -2. So we will have to start with -2 here. Okay. And then the next one is the 1, okay, with the step size, plus the step size. So that's mean -2 plus with h. So that's mean -2 plus with 0.25. Then you get 1.75, -1.75, -1.75, and so on. -1.50. Okay, if you don't have the two calculator that I mentioned, if you have calculator, then you just use calculator, and calculator will help you to do this calculate, so you no need to calculate yourself the next yang seterusnya apa, nilai yang seterus, the next value is what. I open this calculator. Wait, here. Okay, so saya dah ini. So you have to go to the mode here. Okay, you go to the mode here, you find 7, that is table. Okay, table, you go to 7. So we ask you, what is fx? Okay, so you have to key in this formula. This formula. This one, fx is this one. So I have to key in this one. 1 over 1 plus with, saya tekan epsilon, shift, ln, okay, and here I will put alpha x. Okay, so kat sini, and then I press equal to. Okay, so now you will ask you gx. We don't have another function. We only have one function only here. So gx here, you just key in 0. Okay, boleh? So now it start from lower limit. So start from this one, lower limit, -2. So we put -2, okay? And then n. So n, upper limit 0. This one, until 0. How about the step size? Okay, step size is this one. Just now we calculate already this one. 0, 0.25. And then you press equal to. So it come out this table. So you remember when you copy this table, you don't take this one as 1. Start with 1. You have to start with 0. Kalau awak start with 1, nanti awak akan pening n awak. Okay? So later you will confuse your n is odd or even. So make sure when you key in the table, you start the I from 0, this one. But the rest after this one, you can copy. For what I said just now here this is a -2. So you just key in -2. And then -1.75. So you key in -1.75. And then next one, -1.5. Turun lagi. So the next one is 3, -1.25. Turun lagi. Okay. -1. Delete this one. And then -75. Negative, alamak. -0.5. And then -0.25. Okay. Wait. Why just now I mentioned to you, you have to start with 0. Look at here, this is until 9. So you will confuse later on whether your n is even or odd number. So where I said, just now I mentioned before, we only can use Simpson 1/3 rule when the number of segment is even. So that means here start from 0, we get 8 here. So this is for Simpson 1/3 row. Okay, now, okay, go back to this one. If you don't have calculator, then you have to calculate. If you have this calculator, you can see this one. Fx already given this value. So we just key in 0.88078, this one, at here. So this one is the first one. So I will put at here. 0.8808. Okay, so this is the first value. And the next one, the next value is 1. So 1, this is the odd number. So I have to put in this column. So I put 0.85119, no, 20 in this column. Boleh? So because this one is 1, so that I put in the odd. The next one, that is the 2. So I have to put in this one, even. Okay or not? So next one, I will put this one here. Zero 0.8176. I put here. Okay. And then the next one is odd number. Odd number here. So I put here. I will put here. So next one, just press down and then we get 0.7773. 0.7773. And then the next one I will put in even. Kejap. Saya dah dia punya ni tak selari. Sekejap draw this line first.
Excuse me, doctor.
Yes.
The value have to be changed or altered into the, for example, the even value or odd number value, is it?
Sorry, again. Sorry, what
the
you're
numbers,
asking?
Numbers shown in the calculated by the calculator, is FS, right?
Yes.
And now we are obtaining, for example, the row number 1, 0.8807. If we put into the first row, whereby it is odd number, then if the value is 0.7, then we have to manipulate to 0.8. Make it into even number, is it?
You mean if let's say this one, wait, I also not really understand. If you mean, is it when you put wrongly in the table, is it?
No, because what I'm confusing now is that the calculated value is 0.8807, but seems to total seems to be
79, right? 79, right? I just round it up.
Oh.
0.8879. Right, 797. Is it yours the same with me? Look at here. 0.887, 0.88079. So because 9, I just round it up, becomes 8808. Okay or not, Pan? Is it this one you asked?
Yeah. Oh, you just running out.
Oh,
okay,
I round up.
Okay. Thank you.
Okay, and then the second one also same. I also round out. This one, 0.85195. 5, I round it up, this one becomes 0, and this one become 2 lah. That's why mine become 8520. Okay or not, Pan?
Okay, if not round out, it's also okay.
Normally we will round out lah, but it's depending. Okay, if let's say the questions are ask you to do by chopping, then you no need to round out. Okay, if let's say the question only said, okay, do in 3 decimal places, so normally we just have to we have to round up. Okay, now we continue with this one. This one, and then continue with this one. 0.7773, and then next 0.7311, 0.6792, 0.622, 225, If I'm wrong, let me know. And then next one. This one. 0.5622. And the last one. So the last one I will put in this column, 0.5 here. Because this one is the last Fn. Okay. So now, this when we have, oh, sorry. Okay. So I will do the summation of this 3 column row. So that means here I have to, okay, before that, okay, for those who don't have these 2 calculator, that means you have to calculate one by one like this. What? Okay, let's say you don't have these 2, either fx570ex or fx50ms plus you don't have, and you only have the 570ms. So you have to use the calculator to do this formula. You have to key in the formula, this one, 1 over this one. 1 over 1 plus shift this one and alpha x. Okay, so and then you have to calculate what is your x. So your x is -2. Okay, so you key in 0.8808. So you key in, and then your x is -1.75. So you calculate x is -1.75. So you get this one, this value 0.8520. So you key in is here. Okay or not? Okay, so you have to do this one, calculate and key in the value of x one by one. Okay, if your calculator don't have this function. Okay, so now we have to do the summation for all this one. Okay, so daripada sini here 0.8808 plus with 0.5. So I get this one here, 1.3808. And then this one, kejap saya minta siapa. Siapa tolong calculate? No Soleha. Ada buku tak?
Ya, doktor.
Calculate, try calculate.
Sudah.
Dah, cepatnya. Betul ke? Dapat berapa?
Yang mana yang odd ke?
Yes.
Yang odd 2.8707.
2.870. Kejap, saya tengok betul tak? 0.56. 2.8707. Betul ni.
Yes.
2.8707. Okay. Thank you.
Okay.
And now we do this one. 76 plus with 0.7. 311 plus with 0.6225. 2.11712. Okay. So we have this. And then we use the formula, the step number 3. Step number 3 daripada formula just now, remember this one. The formula H, this one, F plus Fn plus with 4 summation of Fi. This one is a odd. Plus with 2 summation of Fi. This one is even. Okay, this formula. So where this one? Okay, kejap. Sorry. This one patut in depan ada ni. Step 3. Here in front of this one lah. From -2 until 0, 1 plus Ex dx equal. Okay. So here actually F0 plus Fn is this value. Yang ni dah. And yang ni, this one is this one. And this one, the summation. the summation of fi for even is this one actually. So you just key in you just put in the value. So this one is 1.3808 plus with 4 times with 2.8707 plus with 2 times with 2 times with 2.1712. Okay, so you get this one. So you get 1.4338. Okay, play. So now you get ready. So far, any questions? Since some wanted roles. Ada masalah? So far okay? Semua okay? Semua okay ke? Okay. Mastura seorang je setiap kali pun macam tu. Where the others? Huh? Okay, okay, thank you. Okay, now we go to the Simpson 3-8 rule. Okay, I explained the Simpson 3-8 rule and then we continue with the example. Okay, so Simpson's 3-8 rule is basically similar to Simpson 1-3-8 1/3. Cuma Simpson 3-8 adalah untuk for those when the subsegment is multiple of 3. Yeah, we go back to just now. Go back to this one. Just on this one. Another one, this one. Oh. Oops. Saya tak sini lah, jauh sikit. So Simpson's 3-8 rule, we have to divide into divide subsegment into multiple of 3. The multiple of 3. So maksudnya setiap kali the n will be like this, and maybe 3, 6, 9, 12, 15, and so on. So have to be multiple of 3. And when we want to find the step size, it's still the same. B minus A divided by n. Okay, so let's say back to previous. Let's say we have I have a 3. Okay, and then saya pecah 3. Okay, dalam ni saya pecah. It can be 4 and so on, but then dalam ni inside I divide into 3. Have to be multiple of 3. So it can be 6, it can be 9. Apa tak keluar? Okay. So let's say this one. Let's say here, this is a A1, this is a A2, this is a A3. Okay. When I want to find the area of A1, okay. So kalau lah untuk this one, Simpson's 3-8 rows. The formula is like this. 3, 8 times H. So F0 plus with 3 F1 plus with 2 F2 plus with F3. So where, okay, start with the A1 first. Let's say A1. We have A1 3 over 8 times with H, the step size. If let's say not given, so we have to find the step size using this formula. Okay, and then this one, okay, let's say this one, X0. Okay, let's say this one X0, X1, X2, X3, X4, X5, X6, 7, tak keluar. So if this one, it will start with the Fx0 plus with 3 F1 di tengah. The first one is Fx1 plus with 2 Fx2 plus with Fx3. And then A2. Kita tengok A2. This one. A2 is 3 over 8 times H times with Fx3 plus with 3 times with X4 plus with 2 times with Fx5 plus with Fx6. Kan? Boleh nampak ni, this one. And then, let's say A3, want to find the A3. So the formula to find the area under the curve for A3 is 3 over 8H. So start with the Fx6 plus with 3 Fx7 plus with 2 Fx8 plus with Fx9. Okay, where the total area is A1 plus A2 plus A3. All right, so you look at here, what we can see here, when we have the Fx1, sini, okay, Fx1 ada 3 kali, okay, and saya silap sini ni. Sorry, wait I check the formula back. Ada saya ada silap sini. Wait sorry, I guess I type I write the formula wrongly. No, have to be, sorry. If you look at, this formula is, actually this is a 3. If you look at the formula at page 133, the equations 6.5. So saya silap. So this is so this should be 3, this should be 3, this should be 3. Okay, that is 3. Okay, let's say now look at this one. 3 times Fx1 and then 3 times Fx2, 3 times Fx4, 3 times Xx5, 3 times Xx7, 3 times Xx8. So you look at here, 1, 2, 4, 5, 7, 8. Actually, kalau ikutnya, it is not the multiple of 3. Boleh. Those values are not multiple of 3. And when we look at this one, Fx3 is a pure 12, 2 kali. And then Fx6 a pure 12, okay? And for sure, this one is the first one and this one is the last one. So that means for those, this is a multiple of 3. So, and then here come the equation of Simpson's 3-8 rule. Dia jadi macam ni. After that, it will become when we have A, B, fx, dx. So it become like 3h over 8. Okay. And then f naught plus fn plus 3 times the summation of fi. Saya akan tulis macam ni tau. Kalau dalam buku, if you look at the book, you will write like this: 3i minus 2 plus with f 3i minus 1, and then plus with 2 summation of f 3i. Okay, and basically this thing, this is the fi. Those are non-multiple of 3. And this, yang ni, this is, alamak, sorry. And this one is multiple of 3. Nampak? Dia ni kan appear 2 times. This multiple of 3. And this also appear twice. Okay, that's why here you have this one. Okay, so this is the formula. Okay, the formula of Simpson's 1/3, 3/8, yang ni kan, this one, yang ni, no need to memorize. What you have to remember is this one. You have to memorize this one. But this one, the equation, if let's say it's come out in the test or final, the equation, this equation will be given. This equation will be given. But then you have to know what is this. Okay, you have to know what is this. This is the non-multiple of 3, and this is a multiple of 3. This you have to know. Okay, but the equation will be given. Okay, so let's try the example. We go back to the same example, but now this time we use Simpson's 3-8 rule. Okay, good class. Are you here? Stay with me, stay with me, stay with me. Are you still with me? Okay, example 6. I think this is should be 6.5 in the book. Bukan 6. Page 134. Okay, so we use the same equation here. Cuma kat sini, we have to solve using Simpson's 3-8 rules when the n is 9. Okay, n is 9 is multiple by 3. Multiple of 3. So, okay lah. Kita boleh guna. Okay, now step 1. Step 1, kita cari apa? We find the step size. So, b minus a divided by n. Okay, if let's say h is given, n is not given. So, you can find the n by using this formula. Dengan dapat, kan kalau step size diberi, lower limit given, upper limit given, but didn't give it the number of n segment. So, you can find this one, n, by using the same equation. Okay, so here h equal to b is 0 minus negative 2 divided by 9. So 2 over 9. So 2 over 9 lah dia punya step size. Okay? Now we have to do this one using, okay, so dah dapat dia punya step size. So now we can draw the table. Okay, if you have calculator, then you can use calculator to solve it. To use calculator yang tadi key in by using table. Okay, if you are using another calculator yang fx 570ex, so I think that is similar. If you want to see, you maybe, because I have this this one emulator, but then I cannot open already because I have to activate the license. So tak beli lah license tu. So maybe I will give you, you can go to my YouTube and then watch the YouTube. I got explained. I think in the minute of 33 something, I got explained using this calculator, if not mistake. I go back to just now, this one. Wait this one. Just get I and then xi. So this one I also key in. Okay, one is f not fn, and then this one is bukan multiple of 3, and then another one is multiple of 3. Not the multiple of 3. Wait. Triple lah. Bukan triple. Saya tulis bukan triple. Not triple. Okay, start from 0. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if let's say if I have table, then I have calculator, then I use this mode table 7. Okay, fx tadi same 1 over 1 plus shift on this one alpha x. So this one equal to, so this one I don't have the another equation. Start from -2 until 0 with the step size. Step size tadi berapa? 2 over 9. 2 over 9. Okay, so dia akan dapat lah macam ni. -2. Okay, kalau lah, if let's say you don't want to do this one, kan tak nak pecah. You want in the, don't want in the decimal places, you want in this one, pecahan, tulis je lah, pecahan. Okay, I just use this one because in your book, using this one, dia guna pecahan. So this one, 12. And then now you just write based on the location. So for example, this one, this value start with 2. This one is the f0. So I put here. I will write here 0.8808. And then the next one, 2 is 2 here, but then actually this is a 1. So 1 is not multiple by 3. So I put here. Boleh. So here, because this one is 1. So 1, 2, I will put here. So, and then 3, akan letak sini. Okay. And then 6, I will put here. Okay. And then the rest, 4, 5, I will write here. 7, 8, also we write here. And then the last one, put here. Okay. So the second one is 0.8554. And then next one, 0.8257. Next, put here 0.7914. 0.7523. 0.7087. 0.66, sorry, 0.66, 6608, 0.60, 0, tak keluar. Wait ah. 0.6093, 0.5553, and then last one 0.5. Okay, macam ni. And then I have to do the summation. Okay, boleh saya copy dalam ni. Summations. Here, this one is 1.3. Ini sama macam tadi. 1.3808, and this one is 4.3067. This one is 1.4522. Everyone okay? Are you okay? Boleh? Semua okay? Semakin kurang. Where are the others? Okay. Now we have to put in the formula. Step 3. Remember the formula just now? Okay. Yang ni daripada negative 2 until 0, 1 plus E x dx. So sama dengan 3H F naught plus Fn plus with 3 time dengan yang bukan triple. Saya tulis macam ni. Plus with 2 triple. Okay. So 3 over 8. H staff size is 2 times with 2 times 2 over 9. And this value, actually, this one, 1.3808. And this value is this one. So plus with 3 times with 4.3067 plus with 2 times with, yang ni sebenarnya, this one is this value. .4522. So you will get 1.4338. Sama kan dengan tadi? Sama. Is it same? With just now 1.4338. Same. So you get it. Okay. Boleh. So why the others left already? They have class or what? So I think actually got another options. Okay. So you remember when we have the segment is even number, so we can use Simpson's wanted row. If we have multiple of 3, then we can use Simpson's 3/8 rows. Okay. So how about if let's say we have an odd number? Macam mana? Tak boleh guna dua-dua? Ke macam mana? Any idea? So, yang mana semua pergi mana lah? Ini agak-agak. If let's say we have n equal to 10, we can use Simpson wanted row. Okay, let's say how about n equal to 11? Boleh tak? Tak boleh. So apa pun tak boleh guna. Aimi, here Aimi. Are you here Aimi?
Ada.
Agaknya if let's say the segment is 11. You guys can use or not?
Tak boleh.
Tak boleh. Actually, we can combine. When we have this one, you see, we can divide it into two. One is we put in the one is 8, one is 3. That it become 11. So that means this one we will use Simpson wanted to solve. Okay, and this one we use Simpson 3/8 to solve. And we have later on we have to combine it together. But I think this one, I will give you example in the next class. I guess another half hour may not enough. Boleh. Lagipun semua dah saturated. I guess your your brain already saturated, right? Dah saturated eh? Okay ke? So I stop sharing. So far, any question to ask? Pan, okay or not, Pan?
So far so good, Doctor.
So far, so good. So I will give you example when we want to combine two Simpsons row together. Maybe take one example because I didn't. Kan dalam buku ada. Saya rasa macam dalam buku tak ada. Dia terus Gauss quadrature dah. Tak ada yang combination. Ada tak?
Tak ada.
Don't have the combination. So I think I will find another example and do the combination. Okay. So we will discuss in the next class. So and then continue with 2 and 3 point Gauss quadrature. Okay. So far.